So here we are on the number 7 for page 4 of trig equations and identities. Find the exact solutions of tangent of x equals pi over the square root of 3 for the domain 0 to 2 pi. Hence, solve the following equations for 0 to 2 pi. Okay, so between 0 and 2 pi, there should be two solutions, two values of x which give us a tangent of square root of 3. The triangle which has a tangent of square root of 3 would be this triangle here, square root of 3 over 2 on the opposite and 1/2 on the adjacent. So that would be a 60-degree triangle, also known as pi over 3. And there would also be a solution which would be this triangle here, which would be 180 degrees plus 60 degrees, also known as 4/3 pi. So there's 1/3 pi and 4/3 pi, and those are the two angles in radians which give you a tangent of square root of 3. Okay? All right, so there are these two. We'll just put that right there. And then now what we're going to do is we're going to take that result and we're going to solve this problem here. Okay? So we're going to draw a little table. And the table is going to have 3 columns. And the first column is going to be x, and the second column is going to be x minus pi over 6, because that's what's inside the tangent. And then the third column is going to be the tangent of x minus pi over 3. Okay, and so what we're looking for in the third column is square root of 3. Okay, and we're going to find all the angles that give us square root of 3. So x minus pi over 6 is the angle that's inside tangent. So we are going to put the two angles that we found so far. Here it's going to be pi over 3, and we're going to put 4/3 pi. Those are the two angles that we know of, which give us square root of tangent square root of 3. And let's take a look at the domain. The domain is 0 to 2 pi. Now, for the expression, if we make the inside expression x minus pi over 6, we need to subtract pi over 6 from both the left and the right. That would give us negative pi over 6 for the left, and it would give us 12/6 pi minus pi over 6, which would be 11/6 pi for the right one. So that would be negative pi over 6 here and 11/6 pi here. Okay? We get rid of this, put it over here. Okay, so and then let's find to see if there's any other angles below pi over 3 and 4 pi over 3 that would give us a tangent of square root of 3. The way we do that, remember, is we just start subtracting pi over 2 from here. So 4/3 pi minus pi over 2, or minus 2 pi, which would be minus 6/3 pi. So it would be negative 2/3 pi. Is negative 2/3 pi greater than negative pi over 6? No, it's not. So we can't do that, okay? So those are the two smallest values we're going to have. Let's add 2 pi to pi over 3. What do we get? We get 6/3 pi plus pi over 3. That would be 7/3 pi. Is that smaller than 11/6 pi? What is 11/6 pi? Or what is 7/3 pi and 6? So if we converted this, it would be 14. If we multiply both the top and the bottom by 2, 14/6 pi, that's too big already. So actually, no other solutions. Okay? Get rid of that solution. So we already found the two solutions. And now what we do is we're going to take our solutions and we're going to, let's see, in order to go right to left, we're going to do the opposite of what we did to go left to right. Left to right, we subtracted pi over 6, right? To go right to left, we're going to add pi over 6. So if we add pi over 6 to pi over 3, that's 2/6 pi plus 1/6 pi is 3/6 pi. That actually gives us pi over 2. Okay? If we add pi over 6 to 4/3 pi, that's like 8/6 pi plus pi over 6. So that would be 9/6 pi. 9/6 pi is actually 3/2 pi. Okay? So those are our two solutions, pi over 2 and 3/2 pi. Let's do C. So C, a little bit of algebra needs to be done here. Tangent squared x equals 3. Let's take the square root of both sides so that we can figure out what tangent x is. That would be tangent of x equals this plus or minus the square root of 3. So, that gives us a whole bunch of angles. We need to find all the angles x which have a solution positive square root of 3 or negative square root of 3. That would be this triangle, that would be this triangle, that would be this triangle, and that would be this triangle. All three of these triangles have a tangent of positive square root of 3, which would be the red and the green one, or negative square root of 3, which would be the orange or the blue one. So, what are these angles actually in radians? So the red angle would be pi over 3. The orange angle would be 2/3 pi. The green angle would be 5/3 pi, or 4/3 pi actually. And the blue angle would be 5/3 pi. Okay? All right. So these are the possible angles which are the solution to that one. We don't even need to make a table or anything, I don't think, because if we look at the domain 0 to 2 pi, I think we've found all the angles between 0 and 2 pi which have a tangent value of plus or minus square root of 3. So we're done with that one too. That was kind of an easy one. Let's look at number 8. Find exactly the zeros of y equals sine of 2x for 0 degrees to 180 degree domain. Okay, so let's see. If we're finding the zeros of this, basically what we're solving is this equals 0. So the way we would make the table for that would be x on the left, 2x in the middle, and sine of 2x on the right. And we're looking for whenever sine of 2x is equal to 0. What angles give us a sine of 0? That would be the 0 degree angle and the pi angle. Okay, so there'd be 0 degrees or 180 degrees. Do you notice I'm writing in degrees here because they asked us with the domain in degrees? That means they kind of want the answer in degrees. Okay. And our domain is 0 to 180 for x, so for 2x it would be 0 to 360 degrees. So here we want between 0 degrees and 360 degrees. Here we want from 0 degrees to 180 degrees. So are there any other angles between 0 and 360 which give us a sine of 0? Well, I guess 360 degrees itself. So 360 degrees is one more possibility, right? If we add 360 to 0, we get 360. And 360 is also included, so we'll go ahead and include that too. And now let's figure out what the x value is for each of the two x values. So if we have 0 degrees was found from x by multiplying by 2. So now we will divide by 2 to get the original x value, so we still get 0 degrees. For the orange value, if we divide 180 by 2, we get 90 degrees. And for 360, if we divide by 2, we get 180 degrees. So our three solutions are 0, 90, and 180. Number 9, it says, use your graphics calculator to sketch the graphs of y equals sine x and y equals cosine x on the same set of axes on the domain between 0 and 2 pi. Okay, that's easy. Okay, let's put sine x and cosine x on the same set of axes. Oh, and by the way, we want to be in radians because it uses radians here. So we'll say mode radians. Oh, it's in radians. Actually, when you turn the calculator on, if you haven't changed it to degrees, it's in radians. So the two, oops, not there, and y equals, please. Sine x. Next one is cosine x, okay? And then we're going to graph it. So there's one of them. That would be sine x because it goes through the origin. And here's cosine x because it doesn't go through the origin. Okay, so it kind of looks weird like that. It looks like DNA, doesn't it? And the domain for the domain 0 to 2 pi. Okay, so if we want the domain 0 to 2 pi, we'll put x min equals 0 and x max equals 6.28 because that's 2 pi. Okay, maybe we should change the y-axis too. Find the x-coordinate of the points of intersections of the two graphs. Ooh, I think we could see that better if we would change the window. Change the window. For x min, we'll put 2. And for x max or y min, we'll put 2, and for y max, we'll also put 2. Okay, and then we're supposed to find the x-coordinates of the point of intersections of both graphs. So let's do that. So there's one there, and there's one there, right? So it will be second calc intersect, which is number 5, and the first curve is sine x, yes. Second curve is cosine x, yes. And you're like, what? You have to choose the curves? Yeah, if there's 2 curves or more, you need to choose the curves, even though it's like totally obvious, right? And I put the cursor close to this intersection first because I want that one first, and it tells me it is 0.785 for the x value. Okay, so the one of the x values is 0.785, and the other x value would be this one here, second calc intersect number 5. First curve, second curve, and then I move the guess cursor closer to this one so that it will give me the second one now. That's close enough. So the intersection is 3.93. Okay, so those are the two x-coordinates of the intersection. And you can kind of see that these are probably special numbers in pi also, although I'm not really sure what special numbers they are. Let's take a look. 0.785 divided by pi is 0.25. Okay, so actually 0.705 is pi over 4. And 3.93 is probably like 5/4 pi or something. One last thing. I forgot to draw the sketch for you. Okay, so if you draw 0 to 2 pi of sine x, remember it looks like that, like from our investigation. And if you draw 0 to 2 pi of cosine x, it looks like that from our investigation. So the two intersections we found is pi over 4 and 5/4 pi. Now let's go to number 10. Find the exact solutions to these equations for this domain. Okay. So this is interesting. This takes a little bit of thinking. Basically what this says is, on the unit circle, when is the sine value equal to the negative of the cosine value? Or when does the y-coordinate equal to the negative of the x-coordinate? Let's see if we can solve this analytically. So normally what we're going to do is try to put all the x's on the left side. How could we put a negative cosine x on the left side? Well, there's two options. One is we could add cosine x to both sides. That doesn't really help because if I have sine x plus cosine x on the left side, that doesn't simplify into anything, does it? So the other possibility is we divide both sides by cosine x. If we do that, we'll get sine x on the left divided by cosine x, and on the right side we get negative cosine x divided by negative cosine x, which is -1. And then we have sine x divided by cosine equals -1. Does that help? What is sine x divided by cosine x? Oh yeah, it's also tangent of x. So we have tangent of x is equal to -1, and we can solve that problem, especially between this domain, right? There's two triangles that have a tangent of -1. There's this triangle, and there's this triangle, okay? So the red triangle has an angle of 3/4 pi, 135 degrees, and the orange angle has an angle of 7/4 pi. So those are the two solutions for this. Okay, let's go to C. So for C, it looks very similar. What if we divide both sides by cosine 2x? What happens then? We'll have sine of 2x divided by cosine of 2x equals square root of 3. Sine of 2x divided by cosine of 2x, that's equal to tangent of 2x equals square root of 3. Okay, what triangle has a tangent of square root of 3? That would be this triangle or this triangle. The red triangle would be pi over 3. The orange triangle would be 4/3 pi. Okay, those are the two triangles that have a tangent of square root of 3. Now, in order to find every single instance, let's draw the table. So the first column we'll put x as usual. The second column we'll put what's inside sine x, which is 2x, and the last column will be sine of 2x. So we're looking for when sine of 2x, or no, I'm sorry, tangent of 2x. And we're looking at this one. So actually the last column should be tangent of 2x. Tangent of 2x. So we're looking for when the tangent of 2x equals square root of 3. So let's see. What triangles give us tangent of square root of 3? It would be pi over 3 in red, and it would be 4/3 pi in orange. Let's look at the domain again. The domain is from 0 to 2 pi for x. What is the domain for 2x? It would be 0 to 4 pi. We multiply the left and the right limits by 2, just like we multiplied the x expression by 2. So we know that for this column, the minimum is 0 and the maximum is 4 pi. Looks like and then for here it would be 0 and 2 pi. Looks like we cannot subtract anything from pi over 3 or 4/3 pi. If we subtract 2 pi from either of those, we'll go below 0. So let's add 2 pi to these. So if we add 2 pi to pi over 3, that would be 6/3 plus 1/3 equals 7/3 pi. If we add 2 pi to 4/3 pi, that would be 4/3 plus 6/3 equals 10/3 pi. And if I add 6/3 to 7/3, that would give me 13/3 pi. 13/3, that is slightly above 4, so that's too many. It's too much. So we get rid of that. We found the last one, right? And then we can just put our 4 pi closer. Put our 2 pi closer. Okay, and so now we have 1, 2, 3, 4 possible solutions. And in order to get the original x value, instead of multiplying by 2 to get 2x, we're going to divide 2x by 2 to get x. So we divide pi over 3 by 2, we get pi over 6. We divide 4/3 pi divided by 2, we get 4/6 pi. 4/6 pi is the same as 2/3 pi. We divide 7/3 pi, we get 7/6 pi. We divide 10/3 pi by 2, we get 5/3 pi. Okay, so I think we're done with that one too. And now we're done with the page.